Hey guys, in today's video I want to talk about the different types of composites you might run into in your own personal projects or if you're in production right now. I don't want to get too into the weeds with all the different variations, but I want to talk about the simple, like this is a bit of a simple triangle that you can work to. They always say that everything has three properties, you only get to pick two. So you have speed, cost, and quality. And the nice thing about this is there are actually three composite construction methods that fit this really well. And I'll go over each of them really briefly, kind of in this video. Might get into them a little bit more later. Also the specific use cases for each one where like you kind of have to ignore this because you are going to end up having to use one over the other. But just to get into it really quickly. So a lot of people that are doing this as a hobby, like obviously what they want is speed and cost because you just kind of want to make something really quick, get it done in your basement or in your garage, and you just kind of want to get something out there to try your hand at it. What you're going to end up finding is that if you're looking at speed and cost, the cheapest way to get into composites overall, period, is going to be wet lamination. So wet lamination is going to be you're buying dry fibers. It could be fiberglass, Kevlar, carbon fiber, other aramid fibers, and resin, either polyester, vinyl ester, or epoxy. And you're going to be using those two things and combining them to make your product. This is probably one of the most ambiguous versions of composites that you're going to see. And it's for good reason. It solves the problem for most people. It's again, very cheap to get into. The setup and teardown is very quick. What you're going to find is you're not going to hit the same quality that you're going to get with the other two that I'm going to be talking about here. Really all you need is the plug or master or mold of whatever you're going to be making. It could even be the part that you just want to copy. You need a release agent, could just be as simple as wax. Then you're going to need whatever fibers you want with the amount of layers that you want and the amount of resin that you need in order to be able to impregnate those fibers. This is the most straightforward version. You don't have to bag it. You don't need to cook it. It doesn't need any other special considerations that the other ones are going to need. It's the easiest to get into. If you can use it to just reinforce things, like let's say you have a crack in your bumper and you just want to throw a quick reinforcement on it, a little bit of epoxy resin, a little bit of fiberglass or carbon, and away you go. You've backed it. That's how they repair boats really quick, is just you grind that material back, slap on some resin, slap on some material, slap on some more resin, you know, back and forth until you get the thickness that you need. Let it harden over, you know, the night, over the weekend, whatever you need. Done. Just job done. It's, again, the easiest to get into, and it's what most people end up doing. You're not going to get the same quality. You're not going to get the same, like, layer adhesion that you would end up getting with the next two that we're going to talk about. You're not going to have the same visual quality that you're going to get from either of the next two that we're talking about. I know that there is, can't remember the name of it off the top of my head. You can put it in the comments down below if you want. I know that you can buy certain carbon fibers that have basically a very light fiberglass mesh on the back that then keeps everything straight and rigid, so you can do some visual stuff with it. But is not going to be at the same quality as, at very least, the last one that we talk about. But the next one is probably going to have a better quality overall, period, just because of the way you're laminating it and the way you can control it while you're laminating it. Going off of that, now, again, there's nothing wrong with wet lamination, but it can only solve certain problems. It can't solve every problem. None of these can solve every problem, but there are certain things wet lam can't do that the next ones would be able to. So going to the next one, if you're looking at quality, but you're still fighting cost, so like you still have the costs are being brought down, but you want to have a higher quality than wet lamination, what you're going to end up finding is your next one's going to be infusion. So infusion is very close to wet lamination, but instead of wetting out the material when it's actually being laminated, so either you wet it out, then put it on, or you put it on, then wet it out. Infusion will be you're actually laminating the mold with dry material, and then afterwards you're putting a flow medium and tubes and bagging and everything else in order to be able to then inject the resin into the carbon fiber structure to impregnate it under vacuum. The nice thing about infusion is you're basically working dry right up until the end of it, so you don't have to worry so much about being able to like covering everything with resin. There's a lot less cleanup that you have to worry about after you're done, but you also have you have better consolidation with the layers, because you don't have each layer kind of floating on top of the next layer with a cushion of resin in between. So you have better layer adhesion because they're actually going to be pretty well touching right up until the point that the resin's actually pulled through it. So you're going to have a stronger structure with infusion in terms of like tensile strength and rigidity than you would with wet lam. The way you'd get there with wet lam is if you just like, again, dump more fucking resin in it, which negates the weight savings of doing composites, but you're going to just have a better product with this. I've heard people say that the worst infusion is better than the best wet lam. I don't believe that. I've seen some really good wet lamination. Again, it solves problems infusion can't. Infusion, you have to bag it. Not only do you have to bag it, you have to have an absolutely fantastic bag. If you're measuring vacuum in millibars, which is pretty standard, you want like a sub 20 millibar. So like 1,000 millibar is basically atmosphere. 0 millibars is total vacuum. Like there's absolutely, like it's space. There's absolutely no air in that. You're going to want to be near 20 millibars. You want to be as close to absolute vacuum as possible in order to get the best draw through your resin. Now, there are people who are going to be like, I don't do that. I get like 100, 200, whatever. You're not going to be as good as a sub 20 millibar. It is what it is. This is what you're aiming for. So the skill is also going to be higher on this. Now, people are going to say like wet lam has a lot of skill. It does, especially if you're not bagging it. You want to make sure that you don't have any voids. You want to make sure that you don't have any bridging and everything else. So there is skill with this. I'm just saying, like, to get that bagging to the next level, you are going to require a high amount of skill to make sure that your infusion is done properly. The last one that we're going to talk about, because I don't want this video to be too long. Again, I can talk about more of these later. The last one I'm going to talk about is basically if you are doing series production, if you are working for any of these like high-end automotive manufacturers and like boat builders and things like that, you're going to be getting into money's still an object, but it's no longer your limiting factor, and your quality level needs to be much higher than you could achieve with either one of these. And it also allows you to have different solutions to problems than you would have had otherwise with these. So like wet lam, you can have a core product in it. You're probably looking at foam or something like that. You can have a core product in here. Infusion, you can also have core products in there. Some of them are like basically it looks like carpet and it just like floods with resin and away you go. There's other ones where it's basically like a hex, like it's like a hex core, but there's a membrane on the top and the bottom, which keeps it hollow. And then there's pass-throughs for the resin throughout it. So it's like, you know, if you imagine the 6 hexes around the one in the middle has a pass-through. So those 6 ones don't have any resin in them. The one in the middle does, and it allows the resin to pass through to the lower layers. These things all exist so you can add structure to infusion and wet lamination. But the last one gives you all of your options. It gives you the highest quality. It gives you the best interlaminate strength, especially when you use something like an autoclave. And it gives you all of the solutions. Again, you have to be able to bag it. You have to cook it in an oven, but it is the pinnacle of this triangle for a reason. So the top one is going to be pre-impregnated Materials. So what pre-impregnated materials are is you basically take a woven sheet of carbon fiber, then you are injecting it, pre-impregnating it with resin, and then you're either freezing it or staging it in such a way that you basically, you don't fully stop it, but you're pretty well stopping the actual curing process of the epoxy resin in it, so you can handle it easier and it has an out life. So while you're using it, it is curing, but it usually is like, you know, a 30-day cure or a 15-day out life. So its out life is outside of the freezer or, you know, anything above 6 degrees Celsius. That's going to be your out life or your working time. But these have the specific amount of resin that it needs to actually cure. So you don't have any extra resin in the structures. You're going to have the lowest amount of weight. You're also going to have the most interlaminate strength, because with that less resin, with the fact that you, for the most part, are probably going to be going through an autoclave. You can do it without going through an autoclave. I did that for years. But the autoclave does help. You're going to have better interlaminate strength because you don't have extra resin going through it, and you don't have to fight with that. You can have all the different core products. You can have like foams, you can have aluminum cores, you can have Nomex cores, right? You have all of the options. The other one is if you want to add hard points in the actual laminate, you can do the same thing here, but you can do like a multi-shot cure where you can do, you know, a few layers, then peel ply, and then cure it. And then you can add all of your core structures and everything after that. And then you can do your final backing layer. So you have like a really clean first layer, but you have all of your structure in there with your hard points. You can mount to it. The nice thing about pre-pregs, again, if you are mounting to the pre-preg, the strength of that mounting point, a lot of it is going to be if you bonded it inside of it or on the back. So you've got your fitting. I'm going to talk about interlaminate strength a lot. If you have, let's say you have a bond nut, right, and you're on top of your laminate, you've bonded this bond nut to the back layer. That's all you've done. The strength of the panel is going to be determined by how strong that layer is bonded to this layer, and that layer is bonded to this layer, and this layer is bonded to this layer, because that's going to affect your shear strength, which is how much force is required to break this part off. So how much force will this bond nut take before it actually gets pulled off of the material, and how much material will come with it? Because if you're breaking this off, is it going to break the last layer off because it has very low interlaminate strength? Is it going to break the second layer off, the third layer off? So when you're doing bonded structures, really this is the kit and caboodle. This is the one that you want. You can get away with it with either one of these. Obviously, everybody does it. Like aircraft are made with wet lamination, like small aircraft. It's fine. It does the job. Just engineer it properly, right? Make sure that this matches all of your requirements. Just you can't control this as much as you can control that. You can't control this as much as you can control infusion. You can't control infusion as much as you can control pre-preg. So this is definitely going to be the top, especially on like hypercars and stuff. You're going to see only pre-preg because it's the best visual quality, is the best strength, is the best performance to weight ratio. This is the one that you're going to be looking at. The one comment I'm going to make before I kind of wrap up this video is please stop calling that dry carbon. This is not dry. Pre-preg has resin in it. That resin is curing while you're handling it. It is not dry. There is a massive difference between dry material and pre-impregnated material. I do not understand how, like, I understand people like to coin terms. I get it. I'm on board. Everybody wants to have like, this is what they're calling it. Okay. But if you call this dry carbon and you get somebody who has an allergy to epoxies, you just gave them the worst rash they're ever going to have in their life if they don't wear like personal protective equipment, like gloves and everything else with this. You're a terrible person. You have to make sure that you specify it is not dry carbon. It is pre-impregnated with resin. If you want to talk about dry carbon, you talk about infusion because you're laminating it dry and you're injecting the resin afterwards. Or you can talk about wet lam before you put the resin on. And then you see the resin going on, so it's easy for you to understand. But if you're going to call pre-impregnated material dry carbon, like there's being factually right, like correct, which is the best kind of correct, and then there's being factually incorrect and just being so like blind to that you're willing to lie about it just to have the thing that you get to say is, well, we call this dry carbon. Who does? You and your brother? No one does. No one in the industry calls that dry carbon. Call Solvay and Torre, ask them for dry carbon. They'll send you a roll of actual dry carbon with no resin in it. Dry carbon has a term. Like, dry carbon as a term has a very specific thing that it is, which is dry, either woven or not woven sheets of carbon. Not pre-preg. Please stop calling it that. So, on that terribly happy note, this is going to be your triangle. There are others on the side, but they mostly involve one of these three things, right? You have like hot formed presses where either you're injecting the resin or it's a pre-preg resin that you're just basically hot forming at 300 degrees. If you look at, giving examples of quick ones really quickly, giant windmill blades. If you see the big electric windmills, for the most part, infusion, they have a core. It's balsa wood. It's actually squares of balsa wood that are sewn together, and they're in big sheets and they lay them down on top of each other. It's really cool. Pre-preg, again, performance cars. Wet lamination, one of the companies I used to work for was small aircraft. That's all we did. That's all we did was wet lamination. If you see people that are making cheap hoods in their garage, it's going to be wet lamination. Some carbon fiber string instruments, wet lamination. You can tell by looking at it. You're just not going to have the same quality level that you're going to have with pre-preg. Do they need it? No. They were engineered to be wet lam. If they're engineered to be infusion, they need to be infusion. Engineered to be pre-preg, they have to be pre-preg. Anyway, sorry, I've wasted a bunch of your time. Thank you for coming back and watching these videos. Hopefully I'll have some more running for you soon. Bye.